And now, dear students, we are going to talk about constructing a straight line. As I promised you, you are going to know how to construct a straight line in an orthonormal system. Here is an example. It says, plot a line D. It is plot or construct or draw or mark a line D. That's how we represent the line between parentheses of equation y equals 2x minus 1. We also write it that way, dy equals 2x minus 1. This is how we usually represent a straight line. Now we use the letters D, small d, or capital D, or small l, or capital L for naming straight lines. Sometimes we use D1, D2, L1, L2, L prime, D prime, whatever. So mostly we use the letters D in its two cases, uppercase and lowercase, and L in its two cases, the uppercase and the lowercase. Now how to plot the line? First step, we have to select arbitrary values for x, so any two values for x. And the note here says that two values are sufficient. So we just choose two values for x, and for each value for x, there will appear a value for y. So for x equals 0, we take 0 because it's the easiest number. So for x is 0, we substitute here 0. We will get 2 into 0. So we evaluate 0 in place of x in the initial equation of the line D. We will get 2 into 0 minus 1. And 2 into 0 is 0, then y is minus 1. So the first point has an abscissa of 0 and an ordinate of minus 1. And this is the first point we care about. So again, it's sufficient to take two values for x, and for each value of x, you're going to have a value for y, a different value for y. Now here is for x equals to 0. Now for x equals to 2, for example, we evaluate 2 in place of x, so we will get 2 times 2, which is 4. 4 minus 1, it's 3. Then the second point is 2, 3. We can take, for example, for x equals 1. Then we have that y equals 2 into 1, which is 2, minus 1, which is 1, and the point we need is 1, 1. We can take also minus 1. If we take minus 1, then we will get, for x equals minus 1, we will get that y equals 2 into minus 1 is minus 2, and minus 1, which is minus 3. And the point is minus 1, minus 3. So that's so simple. This is how to construct a straight line. All what we have to do is to choose two values for x, and for each value of x, we have a value for y. Now, after taking the values of x and y, we organize the points that are in ordered pairs, x then y, x then y, x then y. We plot them in the orthonormal system, and then we join them, and here we go. So here is the figure. Here is the needed point that we used here. That is 0, minus 1, and the other one is 2, 3. So we plot the point 0, minus 1, and we call it A, and we plot the point 2, 3, and we call it B, and then when we join them, we get the straight line. Note that the point, look at the point 1, 1. The third point we take for x equals 1, y equals 1, then we have 1, 1. Look at 1, 1. The line is passing through 1, 1. Here is 1, 1. Look also for minus 1, minus 3. Here is minus 1, minus 3. You can notice that the line also passes through the point minus 1, minus 3. So any point you take will definitely, any 2 points you take will definitely give you the same straight line as taking any other points. And this is how to draw a straight line, or how to construct a straight line. Now we have to know how to check whether a point belongs to a straight line or not. So here is an example. Here are 2 points. A is of coordinates 1, 1 and B is of coordinates -1, -5. We have to check if these points belong to the line of this equation y equals -2x plus 3. So all what we have to do is to substitute or evaluate the coordinates of A in this line and see if we get the result we need. For example, if I evaluate xa in place of x, as you see here, am I going to get ya? Let's see. -2xa plus 3, is it going to give me ya, which is 1? Is the value of xa, which is 1, when evaluated or replaced or put in place of x, is it going to give me y of a, which is also 1? Let's see. So -2 into xa means -2 into 1. Complete the equation of the line, it is +3. Then we have -2 plus 3, which is definitely 1. And when we get this result, when we substitute xa, we get ya, then we say that A belongs to D, and this is how to write the symbol of belongs to. So this is the symbol of belongs to. Now let's see for B. -2 into xb. Again, we are substituting in the equation of the line. -2 into xb plus 3 from the line. Is it going to be equal to yb? Let's see. -2xb means -2 into -1, which is definitely 2. 2 plus 3 is 5. But y of b is -5, and 5 is not equal to -5, even though the only difference is the sign, but they are not actually equal. That's why we say that b doesn't belong to d, and this is how we represent it. b doesn't belong to d. So belongs to has this symbol, doesn't belong to has this symbol. Okay, let's see what we have here. Here we have a note. If a point C belongs to a line AB, then we say that A, B, and C are collinear. Let's say this is line AB. Surely point A and point B belong to line AB because it is called AB. If C belongs to this line, whether here or here or here or whatever, then C belongs to this line, then definitely C is said to be collinear with A and B.